So, welcome everyone. In today's video, we'll explain k-nearest neighbor algorithm, aka KNN. So, at this point of the course, I'm gonna assume you're already familiar with Python and the very basics of machine learning. KNN is a classification algorithm that whenever we enter a new point, it compares it to the old or the training data set points by computing the distance between it and its nearest neighbors. So nearest neighbors here, neighbors mean points. So how many nearest are we talking about? We're talking about k, where k is a constant number. Let's assume it's 5. So we're gonna compute the distance between the point and each other point, and then get the 5 nearest points. And whatever class we have nearer, we have more points in it from the k points we selected, it's gonna be assigned to it. So how are we gonna compute the distance? Well, we have three different ways. We have Euclidean and Manhattan and Minkowski. Okay, so Euclidean distance is the square root of the difference between the x coordinates of the 2 points squared, in addition to the difference between the y coordinates of the 2 points squared. And that's the minimum distance, and that's what we're gonna be using in the coding part. Okay, Manhattan distance is more distance, it's not the minimum distance between the 2 points, but it's commonly used. It's the difference between the x coordinates in addition to the y coordinates, but we don't just get the difference, we get the absolute difference. Okay, so that there is no negative values. Minkowski is a mix between both of them, where we're gonna add the x coordinates and subtract from it the sum of the y coordinates, and get the absolute difference, all to the power of p, where p is a constant, all to the power of 1 over p. So if we substitute p here with 2, it's gonna be just normal Euclidean distance, and that's what we're gonna be using, because in the sklearn we have Minkowski, and we're gonna substitute p with 2, so that way we're gonna be using Euclidean. Okay, so the red line you can see here, that's Euclidean distance, and that's the minimum distance between the 2 points. Okay, so Manhattan, we can only move vertical and horizontal strides, so it's gonna be this, which is larger than these 2 points. And that's Minkowski. As you can see, it's a mix between them, so it moved here diagonally and then horizontally. Okay, another topic we're gonna cover today is the normalization, which we're gonna be using in the coding. So we reassign the value, the current value, let's say it's x, by subtracting the minimum value in the data set from it, and dividing the output of this by the difference between the maximum value and the minimum value. Okay,